Hi everyone. Solana has a reputation for being fast, but fast is a word, not an explanation. In the next 10 minutes, I won't just tell you Solana is fast, we'll see it with diagrams and little interactive demos, no code required. We'll cover why the blocks are so quick, the clock trick that made it possible, how a transaction actually travels, why everything on Solana is a box, where it's used today and where it's heading next. Let's praise it. Start here. Inside the time of one Bitcoin block, about 10 minutes, you can fit roughly 50 Ethereum blocks and about 1500 Solana slots. Watch the tiles fill up. That gap is the whole story. A new Solana block roughly every 400 milliseconds. Here is the same idea as a heartbeat. In the time Bitcoin beats once, Solana beats 1500 times. It's so fast we draw it as a continuous stream while the counter keeps the exact ratio. But low speed isn't the whole point. There are actually two kinds of done. Your wallet says confirmed almost instantly under a second. But true, irreversible finality comes a little later. Around 12.8 seconds today. Remember that number. Shrinking it is the job of the next chapter. Solana's original breakthrough was proof of history, a way to prove time itself. Think of it as a machine that stamps every event in order. Where each stamp is built from the one before it. It is a real chain shared by every node on the network. Now watch what happens if an attacker rewrites a past cell. Every hash after a point changes, so the copy no longer matches the real chain, and the network rejects the whole forgery instantly. Notice the real chain up top never even stops. That's tamper evidence built into time. And now the twist. That invention is retiring. The upgrade is called Alpenglow. Today, bots are recorded on chain and finality takes about 13 seconds. Alpenglow moves bots off chain and targets finality in about 100 to 150 milliseconds. Here is how Alpenglow's consensus voter decides. If round 1 gets 80% approval, the block finalizes instantly. And between 60 and 80, it goes to a second round that needs a fresh 60%. And below 60, it can't finalize and the slot is skipped. One or two rounds, that's it. And it's resilient. Up to 20% of stake can be actively malicious and safety still holds. On top of that, another 20% can simply be offline and the network still makes progress. %, not responding and it keeps going. But push the malicious share past 20 and safety itself is at risk. Two separate limits protecting two different things. So, how does a transaction actually travel? Unlike most chains, Solana has no shared mempool, no big waiting room. Your signed transaction is forwarded straight to the upcoming reader. Follow the packet. Wallet, RPC node, Gulf Stream, reader, parallel execution, tabbing, and finality. When it gets congested, raising a small priority fee helps your packet get included. And here is the Solana superpower. Transactions that touch different accounts run at the same time. That's parallel execution. Only when two transactions touch the same account do they have to wait. Try to place two on the same account and watch them collide. Why is parallel execution even possible? Because on Solana, everything lives in accounts. Think of them as coin lockers. A wallet is a box. A program, a smart contract, is a box holding only code, with no state of its own. Its data lives in a separate box. Splitting code and state apart is exactly what makes learning things in parallel so easy. Now, a common misconception. People imagine one wallet as a single box holding all your tokens together. On Solana, it's the opposite. Each token type gets its own separate account, and each account holds exactly one type. Receive a new token, and a brand new box appears. It never mixes into an existing one. Your wallet simply owns a collection of these boxes. One optional deep cut for the curious, PDS. A normal address sits on the ED25519 curve and has a private key. A PDA is deliberately searched off the curve. We try a bump number from 255 downward until one lands off it. Off the curve means no private key exists at all, so only the program can sign for it. It's a small idea that makes a lot of Solana apps safe. So where does all this speed actually get used? Solana shines wherever actions are frequent and small. Payments and stablecoins, DeFi and DEX, real-world infrastructure known as DP, game, and NFTs. Tap around the map for a one-line example of each. And about that famous TPS number, let's be honest about it. Real user throughput is usually around 1900. And include validator bots and the whole network is 4000 plus. And the 65,000 you often hear, that's a theoretical design ceiling, not a major leap figure. Same network, three very different numbers, so always ask which one someone means. And here is the big picture. Solana's speedup is happening on three layers at once. Inside each validator, a new high-performance client called FireDancer. The full client already carries a low double-digit share of stake, and estimates for the whole FireDancer family, including its Frankendancer hybrid, range from about a quarter up to 40%. Consensus, which is Alpenglow, and between validators, a dedicated fiber network called Double Zero, now connecting roughly 60% of stake. Faster execution, faster agreement, faster wiring, all together. That's Solana, not as a slogan, but as something you can see. Fast blocks, a clock that proves time, no mempool, everything is a box, and a 3-layer upgrade already underway. Everything you saw is a single interactive page. The link is in the description, and it's available in 5 languages. Play with it yourself, and if it helped, a like and subscribe really helps. Thank you for watching. Bye.